Hello, students. Greetings to you all, and welcome back to the physics session. Hope you're all safe and good. So, today we are entering into the sixth video session of 10th ICSE physics. So, what did we see so far? We've been learning about sound. And what did we learn about sound in the previous session? We learned about what is the definition for sound. We learned about the certain characteristics of sound, like its amplitude, frequency, wavelength, wave velocity, and time period. We also discussed the units of all those and what they mean and how they are interrelated, the wave formula. And then we learned about sound as a mechanical wave or an elastic wave and the types of mechanical wave like longitudinal wave and transverse wave. And then we learnt about the difference between light wave and the sound wave. There were a lot of similarities between light. There are certain similarities between light wave and sound wave, and of course there are very many differences between light and sound as well. We saw the difference between light wave and sound wave. And then we saw what reflection of sound means. The law of reflection of light and the laws of reflection of sound are same. They both have two laws. One, the angle of incident is equal to the angle of reflection. The incident ray, reflected ray, and the normal, they all lie in the same plane. And then we learnt about echo. Echo is one way of reflection of sound, and there are certain characteristics of echo, and there are few conditions for echo to happen, and we discussed about the applications of echoes. So this is what we saw in the previous video session for the chapter sound. Now, what are we going to discuss today? The topics that we are going to discuss today is vibration and its types, and then we will be seeing about resonance. The topic may look very simple, and of course, the content is also very simple, but all I need is your 100% attention. So don't get distracted. Give all your attention and listen to the video and to the pictures that you are going to see for better understanding. Okay, first, to begin with, what is a vibration? You know what is a vibration? Vibration is nothing but a to and fro motion. It's more like an oscillation. As you can see here in this picture, you could see certain vibration that was happening both in the case of this and the speaker. So it's nothing but to and fro motion. Things move up and down and it keeps doing it. So a vibration, you can also call it as an oscillation. It's more like an oscillation. So what is vibration? It is a periodic back and forth motion, and you can also compare it with that of oscillation. What are the types of vibration? So there are three types of vibration. What are the three types? Natural vibration, damped vibration, and forced vibration. So we are going to learn in detail about all these three types of vibration. So what is the first type? Natural vibration. We'll see the definition for a natural vibration. Natural vibration is also called as free vibration. The periodic vibration of a body of constant amplitude in the absence of an external force. So see here, there are two important words. One is vibration and the other one is force. So here in this case, what happens is we have a periodic vibration. periodic vibration, and this periodic vibration is happening in the absence of external force. Can there be a vibration in the absence of any force? Do you think that it's even possible? Any vibration can happen only if we give some force. But here, the periodic vibration of a body of constant amplitude, the amplitude is also going to be constant. In the case of a free vibration, it is not only constant, it has a periodic vibration, but in the absence of an external force. And this type of vibration is called as a free vibration or natural vibration. And one example for free vibration is striking a tuning fork by a hard rubber pad. I don't know how many of you know what a tuning fork is. Here is the picture of a tuning fork. It will be like this. And you might have seen in your physics classes, your teacher might have shown you. We will always use a rubber cork. The rubber, with the help of the rubber cork, we will bang on the tuning fork. And what will happen? The tuning fork will start to oscillate or vibrate. It will start to vibrate. And this, wherever there is a vibration, it has a frequency. And what's special about tuning fork is it is the only instrument that vibrates with a single frequency, or it is the only instrument that produces a single frequency. If I have a tuning fork of 420 Hz, it will produce sound of only 420 Hz. If I take a tuning fork of 260 Hz, that will produce sound of only 260 Hz. So this tuning fork is the instrument that produces a single frequency sound. Just keep this in mind. I will be asking this in the next session. You'll have to remember it. Okay, now, so striking a tuning fork by a rubber pad is a example for free vibration. How come you said there won't be any external force, but we have an external force happening on the tuning fork? We are banging on it. Won't you call it as an external force then? Okay, we'll have a better understanding of natural vibration now. Like I told you earlier, what is the type of vibration that's happening here? It is a periodic vibration. So we have a periodic vibration, but there is no external force. Instead of no external force, what is acting here is a restoring force is acting. What is meant by restoring force? Okay, before I could tell you what is meant by restoring force, let's see here. Here is the example for free or natural vibration. Here the amplitude is constant, as you can see here. If it is 1 everywhere throughout the oscillation, the amplitude is 1. There is no change in amplitude, and it is of course periodic. See, it's very periodic. Each cycle takes one maximum, it takes exactly 3 seconds. So it is a periodic vibration and it has a constant amplitude. But there is no external force. Instead of external force, who is acting? A restoring force is acting. So what is the next restoring force? A restoring force is a force which acts on a body to bring it back to the equilibrium position. What is an equilibrium position? For example, imagine, look at the spring, okay? And I am fixing a weight to the spring. So when I fix the weight to the spring, initially the spring will start oscillating. It will go up and down and up and down. But how long will it go up and down? Only for a certain period of time. If I let it go up and down without any disturbance, at some point what will happen? It will come to rest. It will stand in one position. Okay? What brings it to this equilibrium position? The restoring force helps the spring to come to an equilibrium position. Equilibrium position may be to a position of rest. So imagine I am fixing this ball to this ball in a spring. So this is where the ball is. So this is the equilibrium position. Now what I do is I push it inside. What will happen? The oscillation begins. But this is the equilibrium position. So this is the equilibrium position. What is happening? The oscillation happens. When the oscillation happens, it also tries to bring it back to the equilibrium position. Or restoring force is a force that acts opposite to the force that you give. You are pushing the spring up. So that is your force, and this spring tries to come back to its original position with the help of the restoring force, restoring force, a force that acts opposite to that of the force that you apply. So here in this case you are not giving any external force directly, but but this restoring force is going to act as a force on the object, and this is the reason for the periodic vibration. So as you can see, how can a restoring force be useful, or when can a restoring force be useful? So as you can, as you keep listening to what free vibration or natural vibration is, it may sound very absurd and very weird to you because we actually have not seen or experienced a free vibration or natural vibration. It's practically not possible. It is possible, this natural vibration is only possible when we don't have any friction, when there is zero friction and there is zero air resistance. Where can we get the zero air resistance? Only inside vacuum. So this free or natural vibration is possible only in vacuum. You cannot do it. It is not practically possible or easy for us to produce a free or natural vibration. So this is the first type of vibration, that is free or natural vibration. Here the vibration is periodic with a constant amplitude in the absence of external force. Just keep this in mind. We'll move on to the next type of vibration. The next type of vibration is called the damped vibration. It's very common vibration. For example, it's something you all do in your classroom. I know you all miss your classroom so much, but every one of you might have done this. You'll take a long steel scale, stick it in one corner of your writing desk, and you will disturb the scale in one corner. So the scale will start oscillating, it will go up and down and up and down. And at one point, it will come back to rest. So you give an external force on the scale. Because you gave an external force, what happens? The scale starts to vibrate. So initially the scale would have been like this. Once you give this external force, the scale will start vibrating. So it may go up and down, but it will not keep vibrating for a long time. After a few seconds, what will happen? The scale will come back to rest. So what is happening here? Again, here also it is a periodic vibration. But what is happening? A decreasing amplitude happens. In the case of natural vibration, it was a constant amplitude. The same periodic vibration, but constant amplitude. And here what we have? We have a resistive force. In earlier case we said that in the absence of external force, but here a resistive force is present. So we have a force acting on the object. And one more example that I can give is a simple pendulum. You take a simple pendulum, you make it oscillate, it will not oscillate for a long time, it will oscillate for some time and it will come to rest. And another very interesting example is a tree branch. You go near a tree, you jump and you catch a branch, make it move and then you jump down. So this branch will keep going up and down like this, right? It will go up and down for some time and then it will come to a sea. It will be like this. The tree branch will go up and down, and the going up and down will decrease slowly, and the tree branch will come back to rest. So this is what we call as a damped oscillation. In damped oscillation, initially it oscillates more and then it keeps on decreasing and the oscillation stops. So here that is why we call it as a decrease in amplitude. It's a periodic vibration, but here the amplitude decreases. See, the amplitude keeps decreasing here in damped oscillation. And there is a resistive force. Like I told you, even in the previous case, we had restoring force. But here we have a resistive force, and that is the external force. And there are other forces that are acting on the object like gravitational force, frictional force, and so on. So this is an example for damped oscillation. What is a damped oscillation? Initially you will have a high oscillation and the oscillation will keep on reducing and it will stop. Imagine imagine this spring. It is moving up and down. Initially it moves more and then reduces slowly and then it comes to rest. And this is what you call it as damped vibration. Moving on to the third one, that is forced vibration. What do you mean by forced vibration? What do you mean by force? There is an external force involved. So even here, this is also a periodic vibration, and here what happens is you have the influence of an external periodic force. Okay, in damped vibration you had external force, but that external force was not periodic. You jump on a tree, hold the branch and then you just leave. So you give force only once and the tree branch starts oscillating and then it stops. That's all. So the external force acts only once in the case of damped oscillation. But in the case of a forced oscillation, the external force is also a periodic force. So see, when you are sitting on a swing, you will always have somebody standing at the back, right? And this person is very important, the one at the back, because it is that person who constantly will push your swing. It is because of the push that they give periodically, your swing is swinging. Imagine the person who is standing at the back is not at all pushing your swing. What will happen? He is pushing your swing only once, then your swing will oscillate for some time and it will stop. That is damped vibration. Okay. But here, when the person who is standing at the back keeps on pushing your swing after every two or every single swing, then your swing will keep on swinging. So here you give an external periodic force. Okay. When you give an external periodic force, see, you're going to imagine this only with the help of swing. So if a person who's standing at the back is keep on pushing you, every time you go near them, what will happen? The amount of distance will increase, right? What will happen to the amplitude? The amplitude will naturally increase. See here, you are initially at this position. What happens? You are getting a constant periodic force. Here you get one force. So your amplitude increases. Again this person is pushing your swing. So your swing will go even higher and push higher. So when you get a constant periodic external force, your amplitude will keep on increasing. So here again the vibration is periodic and you do have a periodic external force acting on the object, and the other forces that are acting on the object are resistive force and restoring force. Though there is a resistive force, even in the damped oscillation you had resistive force. That resistive force made the oscillation to stop, but here the resistive force cannot stop your oscillation because you have an external force that is keep on acting. That external force is not stopping. So what have we learned so far? We learned about the three types of vibration: natural or free vibration, damped vibration, and forced vibration. And there are so many differences between them. What are the difference between the natural and damped? In the case of natural vibration, the amplitude was constant. But in damped vibration, initially the amplitude was more, and as time goes on, the amplitude keeps on decreasing. In natural, no loss of energy because it is an ideal condition. There is no frictional force, there is no resistive force, so there is no loss of energy. But here in damped vibration, we do have air resistance, we do have frictional force, so there is a loss of energy in the form of heat. In natural vibration, no external force is acting, but here the restoring force is acting on the object. Then, in natural vibration, the frequency of vibration depends upon the shape and size of the body, and the frequency remains constant because it is a it's oscillation with constant amplitude, and the period is also going to be the same. But here, the frequency of vibration is less than the natural frequency. So, what do you mean by natural frequency? Every object will have a frequency on its own. For example, if you take a paper, the paper has a frequency for it. Every object, a wood, a plastic, a glass, even the sand, every object that you look around has its own natural frequency. That is the frequency that is unique for that particular substance alone. Okay. So, in the case of natural vibration, the object will vibrate in its natural frequency. Natural frequency is the frequency that is exclusively for itself. But here in damped vibration, the vibration is less than the natural frequency. And so there are, of course, differences between the natural vibration and the forced vibration. Okay, now we'll move on to a very interesting topic. Seeing what vibration is, the three types of vibration: natural or free vibration, damped vibration, and forced vibration. I told you what is the natural frequency. Natural frequency is a unique character of every substance. Okay, what is resonance? Resonance is actually a combination of free vibration and forced vibration. In free vibration, the object will oscillate in its natural frequency, that is its own exclusive character. It will vibrate in its natural frequency. In forced vibration, the object will vibrate based on the external force that you apply. In resonance, I told you it is a combination of natural vibration and forced vibration. In resonance, it is a special case of forced vibration where the frequency of the externally applied periodic force is equal to its natural frequency. So, two things are matching. It is a forced vibration. Resonance is a forced vibration, but fortunately what happens is the frequency of the external force is equal to the natural frequency of the substance. When two things match, what will happen? Imagine there are two people. Imagine your best friend. You become a best friend of somebody because there is something very similar to you both. Maybe the way you think and the way your friend thinks is very same, so you two became very close friends. When two similar things come closer, what will happen to the bond? You both will become very thick friends. Similarly, here, when the frequency of the external force and the natural frequency matches, there is a heavy vibration. The amplitude of vibration is very large, and so resonant vibration happens. Okay, so resonant vibration is nothing but a very huge vibration. What is the condition for resonance to happen? For resonance to happen, the only one condition is the external frequency of external vibration should match the natural vibration of the vibrating body. There are very many examples for resonance. Number one, vibra- uh, sympathetic vibration of a pendulum. I'll be showing those pictures to you, and then Resonance in machine parts. What is resonance in machine parts? When a vehicle is driven, the piston of an engine makes a to and fro at the frequency depending upon the speed of the vehicle. This vibration, for example, imagine that you are going in a bus. Nowadays you don't go in bus. When you're going in a bus, there is a gear, right? The piston. When the bus is moving, the piston also vibrates. So when the vehicle is moving, there are very many parts in the bus that will vibrate. There are chances that the vibration, when the bus goes, it produces a vibration. That vibration and the natural frequency of some part they match, and that will result in a rattling sound. Rattling is a very huge vibration which produces a sound. And there is something called sonometer or a music box, sound box. And the last one, okay, because the other examples I'll be showing you pictures and I'll try to explain it to you. And the last one, resonance in radio and TV receivers. The radio and TV receivers, they have electronic circuits, and this electronic circuits will have electromagnetic vibration. So here what will happen is the frequency of which can be changed by changing the values of the electronic components. So when you want to tune a radio, we simply turn a valve. So when we turn a valve, what actually is happening is we are tuning the frequencies. So at one particular point, the frequencies will match. So at that point, what happens is you are getting a resonance. And there are few experiments that are being done for resonance, and this is called the resonance tube experiment. So, if possible, when we come back to school, you can. There are chances of you seeing this with your eyes. We have such experiments in our school, and this is one experiment for 11th standard physics. A very interesting experiment. So your experiment setup will be like this. This experimental apparatus will be almost to that of your shoulder. So it's a very huge experiment. And the width of this pipe will be to that of your hands, okay, of your wrist, or maybe your, yeah, almost to that of your hands. This you will call as a YouTube, and this you will call as a reservoir. So what we do is we'll pour water into this. So when I pour water into this, what will happen? This water will go along this tube and it will fill this tube. So always the water level will be same. So what I will do is I can bring this reservoir up and down in order to change my water level in this tube. I'll take a see here. So after setting my water level to certain height, so this is what you call it as the air column. From this tip of the from the mouth of the tube to the level of the water, we will call it as air column. The air column is what we want. The length of the air column is what we will measure. So why I want to change the length? Initially, I'll keep the water at this position, and I will take one tuning fork. I'll bang the tuning fork with a rubber cork, and I'll keep it near the mouth of the glass tube. I will hear some small sound, or maybe I won't then hear any sound. Once I keep on changing the water level, the sound of the tuning fork will change. At one point, the sound of the tuning fork will be very high that even a person who's standing like 2 or 10 feet away from me will be able to hear the sound of the tuning fork. What happens? This tuning fork has a natural frequency, and the air column will also reflect a sound, and that will also produce a frequency. So when they both match, what happens? The sound that is produced by the tuning fork increases. So if you want to understand it better, you have so many videos for this experiment in YouTube. Go to the search and simply put resonance tube experiment. You will be able to see. You don't have to worry about taking down the readings or the formula. All that you have to know is by simply changing the height of the water or by simply changing the length of the air column, you can produce resonance. Resonance is nothing but the high amplitude sound that is being produced. Okay, this may be a little hard for you to understand, but there are certain other very interesting examples I have for you which will help you understand better. I know you all might have seen this. You will have a bunch of pendulums and you will move them all together at the same time, but they oscillate in different directions and with a different speed. This is one. And the other one, I have put one more here. Initially, what will happen? This green is at rest, only red is oscillating. And then red will come to rest, then the green will start oscillating. So, what happens here? It is a and also there are other very many examples. You will have a short pendulum. See here, the heights of the pendulum are different. One is short and the other one is long. So here, the pendulum is make one is influencing the other one to vibrate. The vibration in one pendulum acts as a forced vibration on the other pendulum. So what actually happens here is it is a very good example for forced vibration, but though that it is not just a forced vibration, it is also a resonance that is happening in this particular place, and that is why the oscillation increases. See, initially the oscillation will be less, then the oscillation will increase, and then again it will reduce. So it's a very small animation to show the forced resonance or forced vibration which results in resonance in the pendulum. And this is another example, and is called as resonance with tuning fork. So what we have here is we have two tuning fork, and see when this you just take a moment and observe it well. Initially we have two tuning fork, one small and one big. In that case, when I oscillate the bang the small, nothing happens on the big. See, nothing happens here. But now, both the tuning forks are of same size. So when I simply strike this tuning fork, this other tuning fork also vibrates. This is also called as resonance. They are communicating. The tuning fork you call if you call this tuning fork as A and this tuning fork as B, you call this as A and this as B. They communicate. Both the tuning forks are communicating through the sound box. Here the bottom, what we have at the bottom is what we will call it as the sound box. So through the sound box they can communicate. So the two sound boxes help in the communicating, or it helps in communicating the vibrations and in increasing the amplitude of vibration. This is another example for resonance. And here is a very best example which you will never forget. Can you see this bridge oscillating? Have you ever seen any group of soldiers marching on a bridge? I'm sure you mostly wouldn't have seen it because it is strictly restricted, forbidden. Your no marching troop is allowed to march on the bridge because marching is a periodic function. So they will march left, right, left in a very periodic way. It is rhyming, right? It has some timings. So sometimes what happens is when the soldiers are marching, their marching frequency will match the natural frequency of the bridge. So what will happen when the two frequency match? There will be a huge amplitude in vibration, and this is the huge amplitude in vibration. So whenever you might have experienced this when you're walking on a bridge. When a lorry moves goes on the bridge, you will be able to feel the vibration of the bridge under your feet. But what happens is if this lorry happens to go in the natural frequency, if the lorry can make this bridge oscillate in the natural frequency of the bridge, the amplitude of vibration will be very big. If the bridge is going to continue oscillate like this for a few more minutes, what do you think will happen? The bridge will collapse. So if you allow a marching troop of soldiers to march on a bridge, there are so many accidents that have happened before, that their frequency will match to the natural frequency of the bridge, and the bridge will vibrate very hugely, and it will collapse, it will break. And this is another example for resonance, a glass. You might have seen this in opera. A lady will hold a glass right in front of her, and she will start singing, and when she sings, the glass will break. Is that a magic? No. The frequency in which the lady sings will make this glass also to vibrate. So the when the lady sings, that acts as an external vibration or the external force. This external force, when acts on the glass, and if the glass happens to vibrate in its natural frequency, this is what happens. You can see how much the glass is vibrating. So when it continues to vibrate in such high amplitude of vibration, what will happen? It will shatter and it will break. So what have we seen so far? So far we've seen what is a vibration, what is natural or free vibration, what is forced vibration, and what is damped vibration. And then we saw what is resonance and some examples for all these types of vibration. So children, we've covered a very small portion because the ICSE board has reduced certain portions in your book for your board exams or for this academic year. So I will be telling you what are the portions that have been removed soon, probably in few days. So till then, we'll just try to revise whatever I've told you now. A very small portion has been covered, and all I want you to do is listen carefully and learn all your subjects well and be good and do good to your parents. So if you find it very difficult to understand, I know physics is not a very easy subject for everybody. It is quite tricky and it is quite difficult to understand, but it is an interesting subject, of course. If you find it hard, all I want you to do is just pray before you sit to learn. Now, before you could listen to this video again, I want you all to utter a small prayer in your heart. Lord, help me to understand and help me to do well in my studies. Whatever you ask to God in prayer will certainly be answered. And I promise you that you will excel in your studies and you'll make your parents proud. Thank you, children.